Hi everyone. Again, this is a video on lesson 7. Uh, Looking at some of the questions that some of you sent to me, I decided to go over some of these things uh, so that it would help you to prepare for the test. And then also for those of you who have some problems, because I've been doing these things and then screenshotting them and then sending them to individuals. So what I want to do is that I want to do this video and then explain some of the problems that some of you are having so that it helps. So watch the video, make sure you watch it because it's going to help you understand. And again, it's going to help you with the test 3 that we're going to have after lesson 8. All right, so let's look at section 7.3, square root functions. And we want to look at the key characteristics of square root functions. So a basic square root function has the form f of x equals square root of p of x. That is this. F of x equals the square root of p of x, where p of x is a polynomial and p of x is greater than or equal to 0. Now, why is p of x, which is under the square root sign, why should it be greater than or equal to 0? Remember that we cannot take square root of negative numbers in the real number system. But if it's a cube root or an odd number root, then it's a different story, right? We explained that, or you could understand that in section 7.1 and 7.2. So p of x should be greater than or equal to 0. We don't want p of x being negative numbers, because for square root or an even root, that is going to be a problem. Because if that happens, then you are going into complex numbers. All right. Now, with a basic square root function, let's look at the domain of these square root functions. So the domain, to determine the domain of f of x, you want to find the values of x such that p of x is greater than or equal to 0. Why is that? Remember that the domain is the set of x values, right? The set of possible x values, or the set of possible input values for the specific function. So, because the domain is the possible set of x values, this is how you should think about this. I'm going to go to the whiteboard and then do this on the whiteboard. So if I have f of x equals square root of p of x. Now my domain is a set of possible x values. Now, with my p of x, which is under the square root sign, remember that it should, if p of x, if this function gives me anything less than 0, if it gives me anything less than a 0, then what happens to my function? It's going to be a problem, because the square root of a negative number, that is a problem. I don't want that. So I need values of x that when I put in this function p of x, I should get either a 0 or a number greater than 0. A 0 or a number greater than 0. So for my domain, it is going to be p of x greater than or equal to 0. So when I solve this, whatever I get becomes my domain. So let's say that my p of x is equal to 2x plus 6. So this means that f of x equals the square root of 2x plus 6. So what is my domain? My domain is going to be 2x plus 6 greater than or equal to 0. Now I have to solve this. So I move this across, have 2x greater than or equal to negative 3. I divide by 2, I divide by 2. So x should be greater than or equal to negative 3 over 2. So my x's, so this is just an example, my x's should be greater than or equal to negative 3 over 2, which means that the numbers that I put in for x should be greater than or equal to negative 3 over 2. Because if I put those numbers in here, look, if I put negative 3 over 2, for this, x is equal, which means x can be negative 3 over 2 or any number greater than negative 3 over 2. If I put negative 3 over 2 here for x, I'm going to have 2 times negative 3 over 2 plus 6. Now 2 will cancel 2, right? 2 will cancel 2. So what do I have? I have negative 3 plus 6, which gives me what? Positive 3. Okay? So that is how you should think about it in calculating for the domain of the function. All right, let's go back to our file, our PDF. Oops. Okay. Oops. All right, so if you look at problem 16, if you look at problem 16, we have f of x equals the square root of x minus 2, all under the square root. So determine, so if you go back, I mean, finding the horizontal intercept, let me talk about that, even though I mean, that it's kind of straightforward from all that we've done previously. The horizontal intercept or the x-intercept, and then the vertical intercept. First of all, let's talk about the vertical intercept. So for the vertical intercept or y-intercept, x is always what? 0. X is always 0. So if x is always 0, I put x in equals 0 into the function, meaning that I replace the x with a 0 and then calculate. So whatever I get becomes my y value of the y intercept, which is this guy here. Okay. What about the horizontal intercept? Remember, for the x-intercept or horizontal intercept, y is always what? 0. So if I have the function, this function, oops, if I have this function, okay, let's get a whiteboard. F of x again equals square root of p of x. Now, for x-intercept, remember y always equals 0. Always. Now we know that f of x equals y. So if y is 0, this guy goes to 0, right? So I have 0 equals square root of p of x, like that. Now, the square root of p of x, if I want to take the square root of, what do? I square this part, I square this side too. So 0 squared, of course, that is 0. Now, the square root will cancel the square to have p of x. So this is the reason why finding the horizontal intercept or y-intercept, it is p of x equals 0. So if p of x, okay, if I have a function like that, 2x minus 6. So my p of x is this guy here. So my horizontal intercept is equal to that, or I find it by doing this. Now, what is my p of x? Is 2x minus 6, whatever is under the square root, equals 0. So 2x, I move this there, equals 6. I divide by 2, divide by 2, x equals 3. That's it. All right, so that's how you deal with it. So this becomes my horizontal intercept. When x is 3, y is 0. Why is y 0? Because the rule says for x-intercept, y is always 0. Always 0. All right. So let's keep going. So with problem 16, remember f of x equals square root of x minus 2. So my p of x is what? X minus 2. Now we are supposed to find the y-intercept, the x-intercept, and the domain of f of x. Okay, so let's go to the whiteboard. So we've got f of x equals square root of x minus 2. So first of all, let's find the domain. Let's find the domain. Remember, the rule for the domain is that if you have this p of x, then p of x should be greater than or equal to what? 0. So here my p of x is what? X minus 2, greater than or equal to 0. So x is greater than or equal to, I move this there, I have 2. Right? It changes to a positive. So that is my domain. So x starts from 2 and then goes to what? Positive infinity. All right, what about my horizontal intercept or x-intercept? So from that, I just explained that p of x should be equal to 0. What is p of x? It's x minus 2 equals 0. So you move this there, x equals 2. So this becomes that, and then I have when x is 2, y is 0. Now what about my y-intercept? My y-intercept for that. My y-intercept, remember, for that, x is always 0. So I'm going to have, if x is equal to 0, then I have f of x, which is f of 0 now, equals 0 minus 2. So this gives me square root of what? Minus 2, which is not a real number. So there is no y-intercept. Okay, but this is not a real number. And that's it. Now, problem 17 is a media example, so I'm not going to have us spend so time on that one. Let me show you that one. so that I would have time to also touch on the stuff that I want to touch. Please watch those videos. Okay, please watch those videos because those are going to go a long way to help you. All right, so these are media example, problem 17. So I'm going to go to problem 18. Problem 18. So here we have, given the function f of x equals the square root of 12 minus 4x, all under the square root, determine the domain, the x-intercept, and the y-intercept if it exists. Draw an accurate graph of the function, round to one decimal place as needed. All right, so we've got square root of 12 minus 4x. So looking at this, first of all, let's deal with the domain. Remember, the domain is p of x is greater than or equal to what? 0. What is p of x in this? Is what is under the square root. So I have 12 minus 4x greater than or equal to 0. Now, because the 4x is negative, I want to move it here so it turns to be what? A positive. Now here you have to be very, very, very cautious. If I move the negative 4x, I have 12 is greater than or equal to 4x. If you are going this way, it's 4x is less than or equal to 12. If you are going that way, from left to right, it's 12 is greater than or equal to 4x, right? Okay, so from here to from right to left, it's 4x is less than or equal to, that's how you think about it, or that's how you should view it. All right, so that said, now I can divide by 4, I divide by 4. So what happens? I have x. Now it's less than or equal to what? 3. Okay, and that becomes my domain. It's less than or equal to 3. That becomes my domain. What about my x-intercept? What about my x-intercept for that? What about my x-intercept? Again, at any point, if you want to go back, there is a recorded video. Just stop, go back, okay? Take it back and then rewatch it again. All right. I'm going to erase this and then go to the horizontal intercept. Now, the horizontal intercept says p of x should be equal to 0. And what is p of x? 12 minus 4x equals 0. So I move this there. It's 12 equals 4x. You divide by 4, you divide by 4. So my x equals what? 3 for the x-intercept. So this gives me, when x is 3, y is 0. Because remember, y is always 0 for x-intercept. Always 0. Now, what about the y-intercept? What about the y-intercept? So for the y-intercept, I have x is equal to 0 always. So I'll put that in there. I have square root of 12 minus 4 times 0. So this gives me 4 times 0 is 0, so I have 12. Okay? And then the square root of 12, if I'm going to round to one decimal place, I'm going to have approximately 3.5. So when x is 0, y is 3.5. That's it. Okay, that's it. Now, if you want to get a graph for this, because if you want to go to the calculator, or if you because you have the y-intercept and the x-intercept, okay, you know that y-intercept is right here, 0 and 3.5, and then the x-intercept is 3, 0. So someone would say that, okay, since I have those two, what about doing this? Oops. So my x-intercept is 3, 0, y-intercept is 0, 3.5. Oops, 3.5. So I could do, if that is mine 3, 0, and have that here. And then this is 3.5. Oops, 0, 3.5. Okay, so this can go that way, something like that. Okay, so you have 10, negative 10, you try and then label this, and then negative 10, or you could do 5, 5, okay? You do 5, negative 5, 5, negative 5, and that's it pretty much. All right. Now, what about cube root functions? Cube root functions. All right. So for cube root function, again, we've got a p of x under the cube root. Okay, p of x under the cube root. This we explained in 7.1 and 7.2. Okay. Now, for cube root functions, the domain of f of x is all real numbers. Why? Why? Because with cube root functions or odd number functions, if I do this, oops, let me erase that. So let's cancel this and then put a cube root here, negative 8. Now, a cube root of negative 8 is a real number. So you don't say that this is not a real number. No. That works with square root. That is not a real number. So you don't have to get a negative number under the square root sign. But here is going to work. Why? Because negative 2 times negative 2 times negative 2 gives you what? Negative 8. So the cube root of negative 8 is what? Negative 2. Because if you multiply negative 2 3 times, you get negative 8. So here, the domain is going to be all real numbers. Because whatever number, if it's negative, you put it under the cube root sign, you still get a number. That's what it means. Okay? Now, to determine the x-intercept, again, it's pretty much same as we just did for square root functions. Because remember that for x-intercept, y is always what? 0. So if you equate 0 to cube root of p of x, now to take the cube root of, what do? You cube this, and then you cube the 0. What is 0 cubed? So this cancels out. We have 0 equals what? P of x. So it's the same thing to find the horizontal intercept. Now, to find the y-intercept, again, it's the same format. X equals 0, so you put x equals 0 into the function, and then you get your y-intercept. All right, let's practice. Problem 19. Problem 19, a cube root of 4x minus 8. I'm going to go to the whiteboard, then do that over there. I'm going to go to the whiteboard. What is it again? Cube root of 4x minus 8. 4x minus 8. 4x minus 8. Okay. So we have f of x equals cube root of 4x minus 8. So again, here we are going to be looking at finding the vertical intercept, horizontal intercept, and domain. So I'm going to start with the domain. Domain is what? All real numbers. That is negative infinity to positive infinity, or all real numbers, okay? Now, what about the x-intercept or horizontal intercept? At this point, you should know that the horizontal intercept and x-intercept are the same. So I have p of x, which is x minus 4x minus 8 equals 0. I move this here, I have 4x equals 8. You divide by 4, you divide by 4. So x equals what? 2. So this means that if I have 2 for x, 0 for y. Now y-intercept. X is 0. So I have f of 0 equals the cube root of 4 times 0 minus 8. The cube root of this goes to what? 0. So I have minus 8. So what is that going to give me? Negative 2. And if you put this in the calculator, you should get negative 2. So I have when x is 0, y is negative 2. Like that. Okay? So that's how you solve these problems. Again, it's not difficult. It's all about the practicing. Okay? So practicing makes perfect. So you keep practicing, then things will just fall in place. If you have any questions, send me an email. All right, let's go back to the file. Now we have a media example, so I'm not going to do that one. I'm going to move to problem 21. Problem 21. Problem 21. So here we have cube root of x plus 8. I'm going to go to the whiteboard again. Cube root of x plus 8. Cube root of x plus 8. Now, to find the domain, we know domain is what? All real numbers. The x-intercept, you know that y is always equal to 0. So we get 0 equals, because f of x equals y, so we replace that with a 0, cube root of x plus 8. Now you cube this, and then you cube that. 0 cubed is 0, of course. This cancels out. You have x plus 8. So you move this there. You have the x here equals negative 8. So x equals negative 8. So remember, it's the same thing. X equals negative 8. So we have x equals negative 8 when y is 0. Now for y-intercept, we have x equals 0 always. So f of 0 equals a cube root of x, which is 0, plus what? 8. So cube root of 8, 0 plus 8 is 8, so you have 2. So this means that when x is 0, y is what? 2. That's it. All right. Again, to draw the graph, someone would say that, okay, I am going to go to the calculator and then put it in and then see what graph I'm going to get. Yes, you can do that. Okay, you can do that. But especially when you don't know which form the graph is going to take. Okay, especially when you don't know which form the graph is going to take. So if I'm going to try out my calculator, sometimes it doesn't work well, but I'm going to try it. Try it. All right, so let's try it out. I think we had x plus cube root of x plus 8. So I'm going to go to y equals, clear this, and then I'm going to do cube root, oops, for I have a cube root of x plus 8. Okay, because this is a function, I'm going to clear this. I don't need that. Go up. Now I'm going to move to my window and check this out. So I've got negative 10 to positive 10 for x, negative 10 to 10 for y. So let's try it and graph it. Let's see what we got. So I don't like the way it's like this part. I think that I should just increase this a little bit, this line a little bit, so that I see more of this part. So I see that there's negative 10. The last number here is negative 10. So I'm going to increase this to maybe negative 15 or negative 20. So let's do negative 15. And this is the y part. So, oh, there's the x part, sorry. X part, so I'm going to go to x minimum and then do negative 15. And then hit graph. So you see that now I've got a longer negative section or part of the x-axis. All right. So now I know how this graph looks like. Now with my 2 points, remember one is the y-intercept, the other is the x-intercept. I have those values. I have those values. Okay. So you can see clearly that here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what, when x is 0, y is what? 2. So 0, 2. At this point also we calculated for that. We've got 1, 2, 3, 4, 5, 6, 7, 8. So negative 8. So when y is 0, x is negative 8. So you could draw the graph now. All right, you could draw the graph now. Okay, so I'm going to stop sharing. Oops. All right, so let's go back to the file. Okay. Again, some of these problems are in the media example, so some of these are solved in the media lessons. So I'm not going to go through all of them. Okay. Oops. Oops. Okay. Now let's look at this real quick. Oh, why is this thing doing this thing? Now, radical functions again. This time around, we are looking at the nth root, which means that the nth be negative or positive, right? Negative or positive. Now we know that the nth root could be odd or even number. That is the n, right? The n can be odd or even. So we could have, this is what I mean, we could have a square root of p of x. We could have a cube root of p of x. We could have a fifth root of p of x, we could have an eighth root of p of x, right? Because these are n's. All right. Now, for the domain, when it's even, remember, it's p of x is greater than or equal to 0. You solve that. But when it's odd, it's all real numbers. Remember that. To determine the horizontal intercept, remember that is the same for both of them. You solve whatever is under the square root, the nth root, you solve that p of x equals 0. Now for the vertical intercept, x is 0, you put that into the function. That we also know, okay? You put that into the function. All right. Problem 22 is it's in the media lesson, so I'm not going to do that. But let's look at this guy. So we have a fifth root of 20 minus x. Now, what is the domain? Remember, this is odd. 5 is an odd number, so it's all real numbers. All real numbers. What about the horizontal intercept? Remember, for the horizontal intercept, is the same for both even numbers and then odd numbers. So it's p of x equals 0, which is 20 minus x equals 0. X equals 20. X equals 20. What about the vertical intercept? What about the vertical intercept or the y-intercept? What about that? So with that, for y-intercept, so here we have x equals 20, so 20 and then 0. Y-intercept, x is 0, so you put that into the function, you have f of 0 equals the fifth root, 20 minus what? 0. So we are going to have the fifth root of what? 20. That's what we're going to have. The fifth root of 20. So this, you have to put that into the calculator. You could either do 20 to the power, what? 1 over 5, like that. Right? You could do that. Or you could do as I did when I showed you my calculator. You could also do that. You go to math and then you choose the x and then you put a 5 there. Let me see if I can do that and then show that to you. Let's see if I can get my calculator out there. Okay. Oops. All right. So I'm going to share my screen again, just because I want to use my calculator. Oops. No, why it's not working. Okay, there we go. All right, so now you can see my calculator. So I hit math again, and then I do this. Let's go flare, do 5, and then I go to math, and then I'm trying to hit this because it says the x root, right? So I do 5. Oh, okay, good. Thought it froze on me. Oops. So you see that? So I have a fifth root of what? 20. Then what does that give me? 1.82056. 1.82056. Okay, so that's what you have. All right, that's what you have. So let's keep going. Let's keep going. So to two decimal places, that's what it tells us, to the nearest hundred. So it's 1.82. So when x is 0, y is 1.82 for the y-intercept. Okay. Now let's share the PDF again. Uh, all right. So the next one is an eighth root. Is an eighth root. Eighth root of, says g of x. G of x equals eighth root 8 plus 4x. Eighth root of 8 plus 4x. Okay, here remember it's even, because it's an even root. The nth root is 8. So because it's an even root, the domain is going to be p of x is greater than or equal to what? 0. So we have 8 plus 4x greater than or equal to 0. You move the 4x here, you get a negative 4x, right? Or you could keep that and then just move the 8 there. So I have 4x is greater than or equal to negative 8. You always want the x, the number of the x, or the x part, to be positive. So you divide by 4, you divide this by 4. So you have x is greater than or equal to what? Negative 2. This becomes your domain. X is greater than or equal to negative 2. That's my domain. What about my x-intercept? Remember, it's p of x equals 0. So 8 plus 4x equals 0. When you solve that, x should be negative 2. So x equals negative 2, which means that when x is negative 2, y is what? 0. When x is negative 2, y is 0. Okay? And then the vertical intercept, the y-intercept, you have y-intercept x equals 0. So since x equals 0, we're going to have f of 0 equals the 8th root of 8 plus 4 times 0. What is 4 times 0? Is 0. So we have the 8th root of 8. Oops, the 8th root, let me put that there, of 8. And what is that? Let's use the calculator and see what we got. That should give you 1.30. So two decimal places, 1.30. So when x is 0, you have this to be 1.30. Okay. All right. Mm. Okay, so now we want to use graphing to solve radical equations. So we are going to the graph, okay? We are going to the calculator to solve. What are we solving for? X, which is our horizontal intercepts, our solutions, our intersections. Okay, so we're going to do that. Now, if you look at this worked example, you have this 10 minus 3x, oops, equals 4. Okay, now this can be your y1, this y2. So y2 equals 4. y1 equals the square root of 10 minus 3x. Okay, so let's go try that out. I'm going to share my screen. Sometimes it shows, sometimes it doesn't. Okay, gotta share the entire screen. Let's do this. All right, so we have, let's see if I can find it. Oops. Stop sharing. Go back to the file. Let's look at the problem one more time. We have, oops. All right, so we got the square root of 10 minus 3x equals 4. Okay, equals 4. 10 minus 3x. The square root of 10 minus 3x equals 4. Oops. Okay, oops. There we go. All right, so I go to y. I think my calculator is frozen. All right, just give me about 30 seconds. My calculator is not working well. Okay, so let's go to y, and then we're going to clear this. So we have to put in the, oops, square root of 10 minus 3x, right? So we're going to do square root, second, square root 10 minus 3x. And then you go down, you go to 4. Okay, now I'm going to go look at my window, and then let's say that I create a standard window. Let's see what we get from that. So graph. Okay, so this is what we have. So you could see that I have this point here somewhere there as my intersection. Now, because I'm solving this graphically, I have to solve for my x. So second calc, I hit 5 for intersection, and then I'm going to hit enter, enter, enter. So I have x equals -2, y equals 4. Why is y equals 4? Because my y2 is equal to 4. So that is a linear, okay? Y equals 4, that is a linear. So that is the straight line that I have. Okay, that is the line that I have. All right. Now, let's hit second. again, at this point we have it already, so that's about it. Okay, so that's how you solve this graphically. At this point, you should be able to use the graph, right? You should be able to use that and use it well. You should be able to do that. Okay, so your solution is x value of the intersection, which is what? X equals what? Minus 2. X equals minus 2. That's it. So sometimes if you're not given the choice, or if you're not restricted to solving it directly, but we're going to talk about that also, I think using the calculator or using the graph is really fast. Using that is really fast. Okay, so let's go back. Stop sharing, go back to the PDF, and let's look at it again. So at this point, when you have, oops, when you have that, you are done. You are done at this point. Okay. Now, what about these? These are the problem 25 is in the media example, so I'm not going to, spend time with that. But I'm going to look at problem 27, then we move on. Okay, problem 26. Now, with problem 26, we have, I think, the fifth root of 8x, the square root of 8x plus 133 equals 4. So again, my 4, the 4 is going to be my y2, and this whole thing here, oops, is going to be my y1. So that's how I set it up in the calculator. That's how I do it. Okay, that's how I'm going to do it in the calculator. So you could pick your calculator and then follow me as I do it. You could pick your calculator and then do it as I'm doing it. Okay. Now the major problem here is going to be the window. The major problem here is going to be the window. But we're going to go there and then try solving it. All right. So let's go to the calculator again. Then I'm going to share. Oops. Share screen. Calculator. Now. So I have a fifth root of 8x plus 33. I hope I got that right. So y equal, okay. So y equals the fifth root, right? So I'm going to do 5. Oops, I've got to clear everything. Okay, so 5, then I hit math, and then go to 5 again. Okay, 8x, so 8x plus 133. Okay, and then I go down to y2 is 4, so I leave it as it is. Okay, now let's check window. I have a standard window. Okay, that is fine. So let's graph and let's see what we're going to get from the standard window. So if you look at this, you could see that the line it keeps going, right? And then the graph also keeps going. So they should intersect somewhere over there. Okay, so I've got to increase this. So let's say that I don't know what to do. What am I going to do? So let's say that if I decide, there's the positive x part. So if I decide to do, looking at how it is, I'm going to do, let's say 50, a big number for that one. Now let's go check it out. I don't still see it. I don't still see it. So I think that I have to increase this. So I'm going to go back and then do 100. And I'm going to graph it. I still don't like what I'm seeing, so I'm going to increase it. So I'm going to do 150. Graph it. Let's see if this helps. Okay, it's still kind of something else, but the good news is that I'm trying to find my x. So let's say that I hit second trace, and then I hit 5, and then I hit enter, enter, enter. Give me that intersection. Yes, it did. It gave it to me. It's 111.375 for x. It gave it to me right there. So even though I don't see it so clear or so clearly, it still helps me a little bit. Okay, it still helps me a little bit. So that's how you do the graphing. Use that to solve. Okay, and for getting the windows, always you're smart with it. Okay, look at where you think that you have to increase, where you think you should decrease, and that should help you. That should help you. All right. So we are going to move on to solving this algebraically. All right. So if you look at this problem, this one, you could still do this whole thing. 41 plus, there was 5 times square root of 2x minus 4. Okay, it's not a fifth root. Equals 11. So y equals 11 can be your, it can be your what? Y2. Okay, and then you use that. All right, solving radical equations algebraically. This is the problem we did graphically. Now, square root of 10 minus 3x equals 4. Because I've got a square root, I could square both sides. Then this cancels that. I have 10 minus 3x equals what? 16. Now, I could move the x part to this across the equal sign and move the 16 across also. So both of them would change sign. So 10 minus 16, right, equals negative 3x moves crosses the equal sign, it changes to positive. 10 minus 16 gives minus 6 equals 3x. I divide by 3, I divide by 3. And then my x equals what? Negative 2. And that's what we got from the calculator. Of course, definitely you're going to get the same thing. You're going to get the same thing. Same thing. All right, so let's keep going. Oops. And then, yes. Now, when you get this, you could put what you got into the function to make sure that it's the right answer. So you put negative 2 in there, and then see that from the check, you have 4 on the left side, you have 4 on the right side. So it means this is right. Okay, that's how you do it. Now, what about this one? A third root or a cube root of 2x minus 1 equals 5. So because I've got a cube root, I cube this, I cube that. So that allows me to have 2x minus 1 equals 5 cubed is what? 125. 5 times 5 times 5. So 2x equals 125 plus 1. Why? Because this moves to this across, it crosses the equal sign. So it changes to a plus. So 125 plus 1, I have 2x plus 126 equals 126. I divide by 2, I divide by 2. This gives me 63. So x equals 63. X equals 63. Again, these are not difficult, okay? These are not difficult. It's all about the practicing. Now, there's a media example, so I'm not going to do the next one. I'm going to come to the you try ones, okay? I'm going to come to the you try ones. Now, this one here, if you have 3 times square root, well, the 3 is big, so it's not a cube root, minus 7. Remember, the minus 7 is not under the square root sign. Because it's not under the square root sign, I could first of all move it across the equal to sign. So I have 3 times 4 minus x equals 20 plus 7, which is 27. So 3 times 4 minus x equals 27. Because 3 is multiplying, I can divide through by 3. And what does that give me? 9. So I have square root of 4 minus x equals 9. How can I take the square root of? I square this, I square that. The square root goes off because it cancels. I have 4 minus x equals 81. Minus x, I'm looking for x, so I could move this across the equal sign. It changes to positive. Move this 81 across, it changes to a negative. So I have 4 minus 81 equals x. Please take your time and look at this carefully. Okay, 4 minus 81 gives negative 77 equals x. So x equals negative 77. X equals negative 77. That's what x equals. Negative 77. Okay. What about b? B. We have 5 plus the fourth root of 3x minus 1 equals 7. Now you move this across, you have the fourth root, 3x minus 1, equals 7 minus 5. So the fourth root of 3x minus 1 equals 2. Because I have a fourth root, I put a 4 here, then that allows me, remember you do it on the other side. This will cancel that, the fourth root goes away. 3x minus 1 is equal to 2 to the power 4. If you don't know that, you put it in a calculator. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now I could move this across. It changes to a plus. So I have 3x equals 16 plus 1. So 3x equals what? 17. I divide by 3, I divide by 3. X equals 17 over 3. That's it. X equals 17 over 3. All right. Now let's go to a more advanced problem. So let's say that if you look at what we have here, to solve this graphically, of course, this will be a y2, this will be a y1. Okay? y2 is that y2 equals x, y1 equals square root of x plus 6. But what about to solve this algebraically? Now, to solve this algebraically, I'm going to go to the whiteboard. We want to take, first of all, we want to take the square root off. So I'm going to have x squared. So x plus 6 equals x squared. Now, I could have the x squared stay where it is, but move these two across. If I move the two across, I'm going to have nothing. So I'm going to have 0 equals x squared is staying the same, but x moves across, I have negative x. 6 moves across, I have negative 6. So now I have a quadratic. Okay, so we've already done this. So I look for two numbers that if I multiply, I should get negative 6. Then if I add, I should get negative 1. So what numbers are those? Negative 3 and 2, negative 3, 2, right? So 0, or I could do it the other way, it's the same thing. X squared minus x minus 6 equals 0. So 0 equals x squared minus 3x plus 2x minus 6. So you pick these two, you pick those two. X minus 3 plus 2 x minus 3. Again, these two should be the same in the parentheses. So x minus 3, x plus 2 equals 0. X minus 3 equals 0, or x plus 2 equals 0. So x equals 3, or x equals negative 2. That's it. Okay. Now, here there is another thing you have to do. You have to check. Sometimes, even though you have this, it doesn't mean that that's the end of the story. Now, if you look at what we have in the workbook, now if I decide to put x equals negative 2 into this function, because that is the function we started with. X equals negative 2 into this function, I'm going to have the square root of negative 2 plus what? 6 equals negative 2. What is negative 2 plus 6? I owe $2, I have $6. I could pay my $2, the $2 that I owe, and I still have $4. So I have square root of 4 equals -2. Square root of 4 is 2, and then -2. It's not equal. So you see that? So this is not a solution. But what about x equals 3? What about x equals 3? You are going to see that for x equals 3, oops. What about x equals 3? So we have this, x equals 3, square root of 3 plus 6 equals 3. 3 plus 6 is 9. I have square root of 9 equals 3. So this is a solution. Alright, so checking is really important. Very, very important. Some of you would say, oh, I don't know why I'm getting this wrong. Check to make sure. Okay, check to make sure. That helps. So with these more advanced ones, that's how you deal with them, especially solving them algebraically. Now let's look at one more. Probably let's look at this number, the U try number 32. So I have square root of x plus 6 equals x plus 4. Again, I could square this, then square that. So this would cancel. I have x plus 6 equals x plus 4 times x plus what? 4. Now I still have my x plus 6 here. Now I pick my x, I multiply it by that, I multiply it by that after I do the same thing to this guy, this 4. So x squared plus 4x. Now what about the 4? I multiply it by this, I multiply it by that, plus 4x plus 16. So I'm going to have x squared plus 8x plus 16, x plus 6. Now I've got to move these across. When I move them across, I'm going to have 0 equals x squared plus 8x. I'm grouping like terms. X moves across, it becomes -x, right? Plus 16 is already there. 6 moves across, it becomes -6. So if you think about it, I have my 0, I'm doing it up here. I've got my x squared. Now 8x minus x gives me positive 7x. 16 minus 6 gives me positive 10. Now I've got a quadratic. I've got to solve it. So 1 times 10 gives me 10. I need two numbers that would multiply to give me that. And those same two numbers should add up to give me that. What are the two numbers? 5 and 2. 5 plus 2. So I have x squared plus 5x plus 2x plus 10. So x out, I have x plus 5 plus 2 x plus 5. So I'm going to have x plus 5 out, x plus 2 equals 0. Okay. Now at this point, I know that I don't have an extra space, but I'm going to try x plus 5 equals 0. So x equals -5. And then I have x plus 2 equals 0. X equals what's -2, right? So I've got x equals that, x equals that. But I've got to check. I've got to check because in the end, maybe one of them might not work out. So I've got to check to make sure. So if I check, what do I have? Let's say that now I have two numbers, right? X equals -5, X equals -2. I'm going to erase this whole thing. So let's start with X equals -5. So I'm going to put it in this. So I have -5 plus 6 is equal to -5 plus 4, right? So wherever X is, I do that, equals -1. So this is not equal. So -5 is out. This is not equal. Now what about X equals -2? So -2 plus 6 equals -2 plus 4. So -2 plus 6 gives me square root of 4 equals 2. So 2 equals 2. This is correct. Okay, so X equals -2. Yeah, that's it. All right. Now let's look at this practical problem. This practical problem. So voltage through a circuit is determined by the formula V equals the square root of PR, where P is power measured in watts, R is resistance measured in ohms. Round answers to 2 decimal places as needed. Determine the amount of resistance that is required for 8 watts of power to produce 8 volts. All right, so remember we are determining the amount of resistance. Two options. Someone might decide to do this. V equals square root of the P is 8, and then I still have my R like that. Right? Now, what is my V? My V is 4. So I could also put 4 in here for V. Right? 4 for V. Now, because I've got a square root, to take the square root out, I would square this, and then I'll also square that. So I have 16 equals, the square root will cancel the square, 8R. I divide by 8, I divide by 8. What is R? It's 2. So R equals, there is an R, 2. That's it. Another way to look at this is that someone would pick this and then would decide to do a change of subject, what is called a change of subject. So I square this, and then I square that. This cancels. So I'm going to have V squared equals PR. I divide by P because I know that I'm looking for R. I divide by P. So R equals V squared divided by what? P. So R equals, what is V squared, or what is V? I have 4 squared divided by 8. What is 4 squared? 16 divided by 8. So this gives us what? 2 ohms. It is the same thing, okay? But this one, I decided to do the change of subject and then have my R equal and put the values. It doesn't matter. Whichever one you start with, you get the same thing. All right. Now, what about B? Determine the voltage produced if 121 watts is supplied with a resistance of 40 ohms. So here we've got 30 power, and then we've got resistance. So we are going to be finding the voltage. So V equals square root of what? PR. What is P? In this case, P is what? 121. And then what is R? 40. Right? R is 40. So what do? We multiply. So we are going to have this equal to 4840. So V equals the square root of 4840. And now it's all calculator work. This gives us, I think, 69. Oops. So if you put that in a calculator, it should give us 69.59 volts. That's what it gives to us. Okay, let's keep going. What about the last one? Determine the amount of power that will be supplied in order to produce 100 volts. So V equals, again, square root of what? PR. So we are determining P, right? And then 100 volts. So 100 equals square root of P times 10 ohms. Now, we square this, we square that. That cancels that. So I'm going to have 10P equals 100 squared. I divide by 10, I divide by 10. So my P now is all calculator is going to be 1000. 1000 now. 1000 watts. And that's it. Again, practice, go over them, go over the media lessons, and I think that it should be good. This is not as challenging or as difficult as chapters 5 and 6. All right. Again, if you have questions, send me an email. All right. Thank you so much. Bye-bye.